All right, guys, it's time for the last lesson of Unit 1. Hey! So, direct proofs. Okay, so we're going to do some definitions here. So, a direct proof is a chain of valid deductions that follow logically from assumptions, definitions, or previously proven statements. So let me just talk you through what a proof would be. Okay, let's say you were solving an equation, just a basic equation, and your teacher, me or otherwise, says, explain how you solved an equation. If you've ever had me before, I have you tell me how you do something. So what did you do in this step? Well, what did you do in this step? Well, what did you do in this step? Basically, I'm having you do a proof. You show your work, and then just tell over to the side, what did you do? Okay? And what you do over to the side where you say what you did is called a justification. So a justification is a definition, theorem, or law of logic used in a proof. Okay? A written proof, because what I had you do, or other teachers have you do, is just say it out loud. So a written proof is just putting it on paper, okay? So a communication that tries to express the most important steps in thinking. And that allows people to look at your paper and look at your problem and follow your thought process. Okay? So when writing a proof, you should try to show enough steps and justifications so that another person can understand the argument. Okay? All right, so let's look at this example. Given, a person normally earns $400 a week on an afternoon job, but earns $610 in a particular week working 7 hours of overtime. We need to prove that the person has earned $30 per overtime hour. Let W represent the person's overtime hourly wage. This would have been a Math 1 problem. Okay, so sometimes it's good to solve the problem first, then structure the proof. So we got to set up the equation. Okay, so the equation is, so we work 7 hours of overtime, and W is your overtime wage, okay? Plus the $400 that you normally earn in a week. And that's going to give me my $610, okay? So, how do we solve this equation? If you said subtract 400, that's correct. So step 2 would be 7W equals 210. Now what would we do? Well, now we would divide by 7. And that gives me 30. Okay, so we would say W equals 30. So when you go to do your proof, your first justification is always the given. Okay, that's the thing that you started with. Now, if you will look at the other attachment that I gave you, or the other paper that I gave you that has the properties, I've highlighted, if you'll take a minute, you can pause it, highlight these. Then on the back side, highlight these. These are the ones that you're going to mainly be using for this course. All these other properties are properties and theorems that can be used. Okay? So if you need to rewind that, feel free to do that. Now, when you are subtracting, okay, there's not a subtraction property of equality. So what you're really doing is adding the opposite over here. So what they're going to call this for step 2, anytime you add or subtract, is the addition property of equality. So anytime you add or subtract, and you can put that note over to the side, anytime you add or subtract in an equation, it's the addition property of equality. Same thing happens when you multiply or divide, because really what you're doing is multiplying by 1/7. It's the same thing as dividing by 7. So this is going to be called the multiplication property of equality. So it's just, all we're doing, instead of just saying, well, we did this, is that we wrote the fancy name. All right, let's look at this next one. Prove if 5Q is less than 8Q, then Q is greater than 0. Okay, so the first one, even if you don't know what to do, you better not get the first line wrong, because you just write down the problem. 5Q is less than 8Q. So the first step and the first justification is given. Now, we need to get both pieces on the same side. So we go 5Q minus 8Q is less than 0. So what did I do? And if you look, you also had, give me just one second, let me go back. here we have, you want to highlight these as well. Sorry about that. This is an inequality problem. So we have the addition property of inequality and multiplication property of inequality. So make sure you highlight those two. Okay. And I will let you use your property sheets on a quiz or test. Okay. So that's going to give me, we're subtracting. So remember, when we do any kind of subtracting or adding, it's the addition property, and this isn't an equation. It's an inequality. Okay. Now, that's going to give me 3q is less than 0. Negative 3q. So what did I do there? I just combined like terms. So the property is addition of like terms. And I believe that's a theorem. Give me just 1 second. Let me look on that page. There, yep, it's theorem. Okay. Now, what do we do now? Well, we divide. Remember when you divide, though? Remember when you divide by a negative, it flips the symbol. So Q is greater than 0. So remember, any kind of multiplying or dividing is always listed as multiplication. So multiplication property of inequality. Okay, and if you need to watch that again, feel free. Just rewind it. All right, we're not going to do this down here. We are going to refresh our memory on what the quadratic formula is, because you're going to have to use the quadratic formula just for some basic working problems. Now, one thing you need to know, anytime you have to factor in a problem, any kind of factoring, the justification is always distributive property. Justification is always distributive property. So if you have to factor, then you go, oh, that's distributive property. Okay, so next one, for all real numbers, there we go. That is a what type of statement? Universal. So the if part's your starting part. So if x squared equals k, then we have x equals square root of k and x equals negative square root of k. Remember, your first reason is always given. All right. Now, the next step we're going to do is we're going to get everything on one side. Oops. I want to make 2. This one's going to have 5. I just don't want to have to pick up my pen several times to write that down. All right, so next, get everything on one side. What do we call it when you move something over by subtraction? The addition property of equality. Now, this one's a little tricky. The ones that you're going to have are not going to be this hard. Okay, but we need to get it where we have x equals the square root of k. If you look at this, if this were a square, this would be a difference of 2 squares. So if I wanted to make it a difference of 2 squares, I take the square root of the first thing, square root of the second thing. Okay? One gets a plus, one gets a minus. Okay? And that's going to be called distributive property because we factored there. Because if you do distributive property here, it gives you that. That's why you're allowed to call it distributive property. All right. So the next thing that I am going to need to do if you remember about solving equations with factoring, is I set each piece equal to 0. And if you look through the things that you highlighted, this is the 0 product theorem. Okay? Now, when we go to solve these, we're going to solve by moving this over by subtraction. I'm going to solve this one by moving it over by addition. Now we have what we needed, and this rule is also the addition property of equality. Now, because, and the only reason I'm sticking this on here is some of the questions that you have on your assignment are going to be solve the quadratic, and you're going to need to do that by quadratic formula. Okay, and to refresh your memory, remember our quadratic formula starts by making sure you have everything in order. You have a square term, you have a linear term, which is the plane x, and a constant term. And you pull those coefficients out, okay? And to solve for x, you do the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So you take these numbers out, and what you're going to do is put whatever this number is, you're going to do the opposite of it. And when you get to this part right here, be careful because this is where people make a mistake. So you're going to square this. No matter what this number is, this number is going to become positive. So if this is a negative, it's still a positive because you're squaring it. If it's a positive, when you square it, it's still a positive. Then what I would like for you to do is do -4 times this number times this number. Whatever that sign is what you put here. Okay? So you'll have whatever this number is, and then whatever you got when you multiplied -4 times a times c. Combine those, then take the square root. Okay? And then 2 times a. All right. Thank you so much. If you have any questions, please let me know.